So tangents and cotangents are going to be a little bit more difficult, and here's why. We know a tangent is a sine over a cosine, okay, because a tangent's opposite over adjacent, which in our triangles are always y over x's. So if we're trying to get some points for tangent, let's pick some values that we've used before, like a 0. So if we try and do tangent of 0, we say sine of 0 over cosine of 0. So we make a little unit circle. We put all our dots on there. Okay, this is the coordinates 1, 0. Okay, so because it's on the unit circle, we can use these as sines and cosines. So cosine is 1, sine is 0. So tangent of 0 comes out as 0. If we try and do a pi over 2 now, so we got tangent of pi over 2. It's going to be sine of pi over 2 over cosine of pi over 2. So we come up here. Sine up there is a 1, cosine is a 0, so that's an undefined. Okay, so tangents are going to have asymptotes, okay, but we're going to need some other good points. Now, if we want to do a tangent of a pi, so it's sine of pi over cosine of pi, so we come over here. Okay, sine over there is 0, there's no y value, cosine is here, and we get those three. Okay, that's not really going to help us, just having dots at 0, asymptotes. Okay, so we're going to need some more points. Okay, so let's pick some other values that we actually know. So for these, it may be helpful to throw in our triangles here. So let's make this our 30, 60, 90. So 1, 2, and a square root of 3. Let's make this guy 1, 1, square root of 2. Okay? If we want to do tangent of 0, all right, we already said that guy's 0. So tangent of pi over 6, okay? Remember that's going to be 30 degrees, so we haven't worked with those in a couple days. So we come over here to the 30 degree one. Tangent is 1 over square root of 3. I'm not going to, well, I guess we can rationalize it real quick, just because we've been in that habit. Now, that's a really difficult point to graph because it's a really ugly value. Okay, pi over 6 isn't bad, but that's an ugly decimal, so that's not going to work. Okay, let's use pi over 4, though. So again, that's a 45. So we come down here. Tangent of 45, sines and cosines are the same thing. So now we're getting some better points. Okay, we can work with a 1. Okay, tangent of pi over 3, so that's 60 degrees. So let's come up here. No need to draw a new triangle. We'll just switch what's opposite and adjacent. So this is going to be square root of 3 over 1. Okay, so we're getting some better points with this. Okay, so if we take, well, I guess we got one last one down here. Pi over 2, we've already looked at that guy before, and that's undefined. So now we're starting to get some better values. Okay, we plot the easy ones we can, like 1s, 0s, undefined, and then we let the decimals kind of fill in the rest. Okay, here's what your, so we're going from 0 to pi over 2, so that's not technically enough for us. If we plotted these, we wouldn't get the full period that we're talking about up here. So we could keep going from pi over 2 over to pi, but let's use things going backwards. So let's actually go down to negative pi over 2, okay? And you'll see why this is going to work. Right? So let's redraw our triangles here real quickly. If we're going to go backwards, we're going to be down in quadrant 4. So let's make this the 45, negative 1, 1, square root of 2. Okay, let's make this 30, so negative 1, 2, and the square root of 3. Okay, we've already talked about a 0 again. We know that's 0. Tangent of negative 30 degrees. Okay, so the same thing as tangent of 30, just now negative. So we come over here. There's where we get the negative 1 over our adjacent. Okay, we rationalize this. Now we're getting some values below the x-axis, which is good. Okay, negative 45 degrees here. So come up to this triangle, same as positive 45, just check your signs. That guy's a negative 1. Okay, negative 60 degrees. Let's just go to this guy. Actually, let's draw a new one just so you guys don't get confused. So here's the 60. So here's your 1, here's your 2, here's your negative square root of 3. So tangent is opposite adjacent, and tangent of negative pi over 2. So let's come down here, 0, negative 1. So this becomes sine of negative 90 divided by cosine of negative 90. Okay, we take that value right there. Negative 1 over 0 is an undefined. So now we actually have enough to see what this thing is going to look like. Okay, if you want to take that little, excuse me, that little chart that you guys have that you filled in your sines and your cosines, and you want to include these for tangents, these are going to be our 5 main points for a tangent. So we're not going to use those ugly decimals. Okay, we're going to use 2 asymptotes, a negative 1, a 0, and a 1. Okay, so we're going to use these values. Negative half, negative fourth, 0, fourth, and a pi over 2. Okay. This is what your tangent looks like. If you take that table and you match it up. We said we had asymptotes here and here from our table. We had said we had a value of 0. We said we had a value of 1 and negative 1. Okay, so tangents kind of grow here. They get more and more positive. So tangents are negative down here. Tangents are positive. So if we consider this little range right here, we're starting with negative tangent values. We're coming around, we're getting positive tangent values. Okay, we hit third quadrant, starting over here. Tangents are negative still, which is represented this guy down here. We hit fourth quadrant. Tangents are now positive, which represents this guy coming up right there. Okay, so we use those decimals in there, and they kind of have this little curve. So it kind of goes up here on the bottom, like this, and then it curves back under coming up this way. Okay, so that the square roots of 3, the square root of 3 over 3 are all taken care of in here. Okay, and they're bounded by the asymptotes. All right, with the tangent, nice thing is this is one full period. Okay, so your 5 points would be asymptote is 1, 2, 3, 4, asymptote is 5. Okay, so the periods are cut down some. So if you want to take a sheet of graph paper and add a tangent graph on, at least a period or two, so maybe from here to here, so you know what they look like, that would be helpful as well. Okay, once we have a tangent, all we got to do is reciprocals to get a cotangent. So if we use these for a tangent, we're going to use these over here for a cotangent. Okay, so if we reciprocal an undefined, well, an undefined used to be 1 over 0. So if we reciprocal that, this is now going to be a 0. If we reciprocal in negative 1, we still get that. This guy used to be 0 over 1, so if we reciprocal that, we now get an undefined. Okay, and we continue this process. Okay, we'll get some points we can use for a cotangent. Here's what your cotangent looks like.